Okay, so last time we started talking about log functions, section 4.2. We're going to finish up section 4.2 today. So let's take a real quick second to review a little bit of the stuff we did last time. So the first thing we went over last time was switching back and forth between exponential functions and logarithmic functions. You just took a quiz over that. Let me see if I can remember some of the problems. One of them was 7 squared equals x. What form is that currently in? That's currently an exponential function, right? If I want to switch it over to log function, it's log, what's the base? The base is 7. So log base answer, this equals x, equals the exponent, which is 2. Okay. I can't remember off the top of my head what a log was, but if we had like log base 3 of x equals 5. That is currently in log function. If I want to put it into exponential function, the base of this log is 3. The exponent that I need to raise that to is the answer of the log is 5. And it equals what you're taking the log of. It equals x. Okay, so that's what we went over last time. The other thing we went over last time was evaluating logs. We just got into that. So let's do a few of those. So evaluating, this is actually figuring out a number for the log. This will be on your quiz next time, evaluating log. If I had log base 2 of 8. You may not know off the top of your head what that is, but you can switch it into exponential form. So we're trying to figure out what this equals. If I switch it over into exponential form, this says 2 to what power equals 8. Well, that's pretty easy to figure out. 2 to what power equals 8? 2 to the 3rd power. So my answer for that is 3. What else? If I had log base 5 of 1 over 25. Trying to figure out what that is. If I switch forms to my exponential form, this says 5 to what power equals 1 over 25. Yeah, if I want to turn a whole number into a fraction, I raise it to a negative exponent. In this case, I need to square it also. So it's 5 to the negative 2 power. So my answer for this is negative 2. What about if I had log base 25 of 5? If you change forms there, that says 25 to what power equals 5? How do I get from 25 to 5? Yeah, you got to take the square root, right? Square root of 25 is 5. And the power for taking the square root is 1/2 power. So this would be 1/2. Okay, we are going to get into some properties of logs. That's all the evaluating. Yeah, let's get into the properties of logs. These are nice because these make problems go a lot faster if you know the properties of logs. So the first property is, let's do an example first, and then I'll tell you what the property is. If I had log base 7 of 7, and I'm trying to figure out what that is. If I switched forms, that says 7 to what power equals 7? What's the answer here? 7 to what power equals 7? 7 to the 1st power, okay? So the property says that anytime the base and the thing you are taking the log of are the same thing, your answer is always going to be 1. And that should make sense because it's going to be whatever something to what power equals the same something. Well, it's always going to be the 1st power. So the property says if I have log base b of b, that always equals 1. And that's a good, it's not bad to not remember it because you can always switch over to the other form, but it's a good thing just to recognize if the base and the thing you're taking the log of is the same number, it's automatically 1. Okay, so that's the first property. There's another property, and the example is if I had log base 5 of 1. If I switch forms, equals what? That's what we're trying to find. If I switch forms, this says 5 to what power equals 1? Yeah, 5 to the 0 power equals 1, right? So the answer for this is 0. The property says log base anything of 1 would always be 0, right? Because anytime I raise anything to the 0 power, it always equals 1. So the property says log base b of 1 is always 0, no matter what. Okay, there is two other properties. These are the most common that you're seeing. Two other ones, these are called inverse properties. And when we start solving equations, properties, when we start solving equations with logarithms, these will come in handy then. The inverse properties, let me do an example for this one. If I had log base 7 of 7 to the 3rd power. Okay, if you switched forms here, the base is 7 to what power equals 7 to the 3rd? It seems kind of weird because it's so like obvious. What's the answer here? What power do I need to raise this to make it equal 7 to the 3rd? 3, right? So yeah, the answer for that's 3. So essentially, it's kind of like this whole thing cancels out and it's just the exponent. Because if that was a 5, the answer would be 5. If that was a 10, the answer would be 10, right? So the property says if I have log base b of b to some power, I'm going to say the x power, the base of your log and the base of this exponent both have to match. And in that case, the answer is always whatever your exponent is. Similarly, I'm just going to go and tell you this was the property, by the way. I'm just going to go and tell you the property for the other one because it's kind of confusing. But the other one is if I have some base in exponential form raised to some log base b of something, the base and the log base b cancel out and it's also just x. The reason why these properties happen is because exponential functions and logarithmic functions are inverses. We looked over when we were graphing the exponential function last time, we talked about how it passed the vertical line test, it passed the horizontal line test, so it does have an inverse. A logarithm is an inverse. It undoes an exponential function, and an exponential function undoes a logarithmic function. So it should kind of make sense that if I'm taking the log of something to an exponent, it like undoes it. Okay, same thing here. If I'm taking something and raising it to a power, but I'm doing a log, it's like undoing the power there. Does that kind of make sense? Okay, so let's do some problems. Let's evaluate some problems using our properties. Do I not? Ah, there we go. So if I had the problem log base 2 of 64. This is a problem that you can just work out and get the answer, or you could actually use a property for this if you wanted to. If you wanted to use a property for this, the idea is I need to rewrite 64 as 2 to some power. If you wanted to, you could do it that way, or you could switch forms. If I switch forms, I would say 2 to what power equals 64? What's the answer for that? I think that's 32. 2 to the 5th is 32. I think it's 6. 2 to the 6th power is 64. So the answer for that would be 6. If you really wanted to use a property for that, the way you would use a property is rewrite 64 as 2 to some power. well, it's 2 to the 6th power. And then can you see how it kind of cancels out there? You get the answer of 6. What about if I had log base 2 of 2 to the 4th power? That one would just be 4, because the log and the raising it to an exponent undo each other. What about if I had log base x of 1? Yeah, that's one that once you do it over and over, you'll start to remember it. If you need to change forms, that's fine. If you change forms, this would say x to what power equals 1? Well, only thing to get 1 would be 0 power. So the answer for that is 0. What about if I had log base 5 of 5? Yeah, log base 5 of 5. If your base and the thing you're taking the log of are the same, your answer is just 1. And one more, if I had 3 to the log base 3 of 5 power. Yeah, it's kind of like this 3 and log base 3 like undo each other, and I'm just left over with 5. Questions about that? Okay, you need to go to your note sheet, and I uploaded that on week 10 also if you are on Zoom. There is a graphing one for logarithms, so we're going to do that. Okay, so for logarithms, remember we talked about how you can't, if we're graphing this function right here, log base 2 of x, we can't really type in log base 2 of x on our calculator, because on our calculator, the log is base 10. And we'll talk more about that in just a minute. So it's kind of difficult to graph, to make a table of values and to graph logarithms. You can really think hard about it and think about what numbers you want to plug into x to make it work. Like I could plug in 1 there, right? If I plugged in 1, log base 2 of 1 is 0. We just did that. I could also plug in 2, right? Log base 2 of 2, what is that? 1. Okay, would I want to plug in 3 here? Not necessarily, because that would be a decimal. Would I want to plug in 4? You could. Okay, so if you really, really think hard about it, you could sit here and pick a table of values. A way to do it a little bit easier is the inverse of this function is the exponential function, right? Let's change forms here. If I change forms, this says, I'm going to write this as y equals log base 2 of x. If I change forms, this says 2 to the y power equals x. Right? And then the inverse, you just switch your x and y. So actually, y equals 2 to the x power. That is the inverse of this function. The question is, why would I want to find an inverse? Well, it's a lot easier to make a table of values for y equals 2 to the x power than it is log base 2 of x. If I made a table of values for my inverse, how would I find the table of values for my log? Switch them, just switch the x and y and solve for y. So let's make a table of values for the inverse first, and then we're just going to flip them to actually get the table of values for the log. Okay, so this is my x, this is my y. Let's do -2, -1, 0, 1, 2. If I plugged in -2 to my exponential function, 2 to the -2 power. Or technically, you could do this on your calculator, right? That one's easy to type in on your calculator. Y equals 2 to the x. And I want to go to the table. If I typed in -2, I would get 0.25. 1/4, because this is 2 to the -2 means 1 over 2 squared, which is 1/4. I could plug in -1 and get 0.5, because that would be 1/2. 2 to the 0 power. What's 2 to the 0 power? 1, 2 to the first power, 2, 2 to the second power, 4. Okay, this is not what I graphed because this is the inverse. This is the exponential function. To actually get the log base 2 of x graph, I need to flip my x and y's, right? So my x values now would be 0.25, 0.5, 1, 2, 4. And my y values would be -2, -1, 0, 1, 2. Doing those in our head, we got a few of those. We got 1, 2, and 4. It's this piece over here that we wouldn't really get. The other part of the graph you wouldn't really see because it's kind of difficult to come up with those in your head. When I go to graph this, I'm going over 0.25 down 2, over 0.5 down 1, over 1 up 0, over 2 up 1, over 4 up 2. And you can kind of see that your graph's going to continue to get bigger this way. And then is it ever going to actually touch the y-axis or cross over the y-axis? No, because if you think about it in exponential form, I'm plugging in bigger negative numbers. I'm just getting a bigger decimal or a smaller decimal closer to 0. Okay, so it's never actually going to cross. You can't get a negative number. And that tells us something very, very interesting. Without transformations, can a log equal a negative number? No, you can't get a negative number over here. Well, I'm sorry. Yes, a log can equal a negative number. Can you take the log of a negative number? No, you cannot take the log of a negative number because the idea is if I was trying to find log base 2 of, let's say, -4. 2 to what power equals -4? I can't raise something to an exponent and get a negative number. So you can't take the log of a negative number. That's why our domain is restricted to the positive quadrant over here. What is the domain of this log function? 0 to infinity. 0 is not included. That means that we also can't take the log of 0. Okay, so that we said this one was undefined. Think about it. 2 to what power equals 0? Can I turn 2, can I raise 2 an exponent and turn it into a 0? No, I can make it a negative number. No, I can't make it a negative number. Sorry, I'm thinking of this off the top of my head. I don't have this written down. I can make it into a decimal because I can take the square root, the cube root, the fourth root of 2, right? I can get a really, really small decimal. I can't make it into a negative number. Right, because we just went over that. So that's the reason why it can't be 0 and it can't be negative numbers. What's the range of this function? Negative infinity to positive infinity. What is the x-intercept of this function right here? 1, right? The ordered pair 1, 0 is the x-intercept. That's actually the x-intercept of all logarithmic functions that don't have transformations on them. So if this was log base 3 of x, log base 5 of x, log base 7 of x, why is the x-intercept for all functions 1, 0? Yeah.
Because when you plug in, like when you raise something, it has to do with the powers. Equal 1. Based on the same.
It's because of this property right here. Log base anything of 1 equals 0. So this is the y value. That's the x value. So 1, 0. Okay. If my base, in this case, my base was 2, if it's greater than 1, this graph is increasing. If my base is in between 0 and 1, if it is a fraction, 1/2, 1/3, 1/4, 1/5, it would be a decreasing log function. Do I have a vertical asymptote here? Yeah, technically right here on the y-axis, right? Because it can't equal 0 and it can't be negative numbers. So I have a vertical asymptote at vertical is x equals 0, which is the y-axis. Okay, so let's talk about specific types of logs. We're going to talk about a common log and a natural log. Okay, so common logs. Common logs are log base 10. Okay, so any log that is in base 10, that is called the common log. So like log base 10 of x or log base 10 of something. Yeah.
Is it still 4.2?
Yes, still 4.2. We're finishing at 4.2 today. When you have a common log, log base 10, you don't have to write the base. It's kind of like the idea of cube root, I have to put a 3 right there. The fourth root, I have to put a 4 right there. For square root, do I have to put anything there? We assume it's a 2. We understand it's a 2. Same thing with logs that don't have a base written down. We assume and understand it's a 10. Okay, so if I wrote log of 100 in my head, and if I'm trying to evaluate that log of 100, I automatically know it's base 10. It's fine for you to write base 10 in your answer. It's kind of like writing 1x equals 7. Do you need to write the 1 there? No. Is it wrong to write the 1 there? No. It's just extra information. So if it helps you, feel free to put a 10 down there, because then it might be easier to figure out that answer. If I change forms, this says 10 to what power equals 100, 10, which would be 2. So my answer for that would be 2. Okay, so common logs are on your calculator. If you look on your calculator, there is a log button right here. It does not have a base on that log, so it tells you that's a common log, log base 10. So you could have typed that problem in your calculator. Log of 100 is 2. Okay. Let's do log of 1,000. What's log of 1,000? Use your calculator if you want to. Or switch forms and do it in your head. It doesn't matter. Log of 1,000 is 3. Why is log of 1,000 3? Well, because 10 to the third power equals 1,000, right? You could find log of any number. What's the common log of 5? Log base 10 of 5. Type in your calculator. Log of 5 is that decimal, 0.699, if you wanted to round it. Okay, so log without a base is log base 10. This is going to come in handy later on because we can switch, especially when we're solving equations, we can switch these forms into log base 10 so that you can put it on your calculator and evaluate it a little bit easier. Okay. So that is one way we can get in your calculator. Oh, real fast. What about if I did log of -3? You can't do it. Why can you not do it? Because I can't put in a negative number into a log. The idea here is 10 to what power equals -3. I can't take any base and turn it into a negative number. You can also check that. Log of -3. Undefined. Yeah, there's no solution for that. No solution, undefined, whatever you want to. What about log of 0? Wrong way. Can you take 10, raise it to some power to get 0? No. Remember, the domain is undefined at 0. So log of 0 is also going to give you an error. Okay, so that is one of the logs you can put in your calculator. The other type of log you can put in your calculator that we are going to start using a whole lot is called the natural log. The natural log. The natural log looks, okay, so natural log is base E. So essentially the natural log is log base E of anything, X, 10, 12, 100. And the way we determine this based from other ones, it's kind of annoying to write that E at the bottom. So they write it as LN for natural log. So if you see LN, all that means is log base E. And if you want to rewrite it as log base E, that is totally fine. But just know that LN is a button on your calculator that's going to be helpful. Okay, so let's find the natural, and I'll just warn you right now, for some reason, when I do natural logs, I start writing my L's in cursive just so that it doesn't look like a 1, because it kind of looks like 1 N. Okay, so natural log of 5. If you want to rewrite this as log base E of 5, that's fine. Just know to put it on your calculator. I have a button. It's below the log button. It says LN. Okay, so natural log of 5, when I type it in my calculator, I get 1.609. 1.609. Another thing that will help you kind of remember what the bases are, if you look on your calculator, on the graphing calculators, look at what's above. So log, above it in blue, it says 10 to the x power. It's because those are inverses. This is log base 10 versus 10 to the x power are inverses. Here, natural log, the base is E. I don't know if you can actually see that. The base is E. Look above it, E to the x power. Okay, so that kind of helps you remember what the bases are there because those are inverses. Okay, so let's do a couple problems with the properties. Yeah, we got time just for a couple. Using the properties of natural logs and common logs. Okay, so if I had natural log of 1, what's the natural log of 1? Type in your calculator if you wanted to. 0, right? Because e to any power, I'm sorry, e to the 0 power equals 1, right? Any base to the 0 power equals 1. So it doesn't matter. It's taking the log of 1 is always 0. What about the natural log of e? If it's helpful, write it as, this is log base e of e. Does that help you see it? What's that going to be? 1. Remember our property that says if your base and the thing you're taking the log of are the same, they like cancel out essentially and you just get 1. What about if I had natural log of e to the 5th power? It's 5. If you couldn't see it, you could rewrite it as log base e of e to the 5th power. And remember those like undo each other. And I just get 5. What about log of 10 to the 5th power? Yeah, remember this log has a base of 10. You could write a 10 there if you wanted to. And same idea, log base 10 of 10 like undo each other, and I'm left with 5. Excuse me. What about log of 1? What's the log of 1? And remember, like you can put all of these, you can technically put it in your calculator. Log of 1 is 0. You could have even put that last one on your calculator. Log of 10 to the 5th power is 5. Okay. As long as it's base 10 or base E natural log, you can put it in your calculator. Okay, so next time on your log quiz, you may have us changing forms, but most of them are going to be evaluating. Okay, so it's not going to be multiple choice next time. It's going to be a blank, and I'm going to say, what's log of 1? And you type in 0. What's Natural log of E, it's 1. You type in 1. Okay, so make sure that you're prepared for your log quiz next time. And that's all of 4.2. So you can do your homework on 4.2. Let me know if you have any questions, and I will see y'all next time.